anomalous behavior of water, which is very important for aquatic animals for their survival. Now, as it is very important point, we will just revise once again. Now, regarding anomalous behavior of water, we know actually when we decrease the temperature of any substance, it acquires the solid state. And at 0 degree Celsius of any substance, the density is greatest. In case of water also, it is must, because at 0 degree Celsius, when we freeze the water, it is converted into its solid state. Means at 0 degree Celsius, water acquires its solid state. Now we know when solid state is acquired by a substance, its density must be greatest. According to that rule, water also must have the greatest density at 0 degree Celsius. But it doesn't happen. In case of water, the density of water at 4 degree Celsius is highest, is greatest. As the temperature of water is decreased below 4 degree Celsius, its density again starts to decrease and its volume increases. Means it is just abnormal behavior of water, and this abnormal behavior of water is called as anomalous behavior of water. Now, yesterday we have studied this with the help of Hope's apparatus. Once we will revise that. This anomalous behavior of water or abnormal behavior of water is explained by scientist Hope with this apparatus. As this apparatus is made by Hope, this apparatus is called as Hope's apparatus. Now, in this apparatus there is a jar containing the surrounded one portion of this jar, upper portion of this jar by a trough in which freezing mixture is situated. Now, what happens when we fill water in this jar? Then at this area where the freezing mixture which is covered, which is surrounded by the trough containing freezing mixture, at that part of the jar, the temperature of water is reduced. As it acquires the temperature of 4 degrees Celsius, according to anomalous behavior of water, the water gets the greatest density. Its density, as it is density is highest, it reaches at the bottom of jar, and the water which was at the bottom, it comes upside due to its less density. In this way, the jar is filled up to this portion, up to the portion where it is surrounded by trough containing freezing mixture. And when this whole water gets the temperature of 4 degrees, its temperature starts to decrease again. As the decrease in temperature is started, the density of water starts to decrease and volume of water starts to increase. As density is decreased, this lighter water comes and is situated in above portion of the jar. Means, in all, the water upside of the jar is of 0 degree Celsius continuously, and the water present at the bottom of jar is of 4 degree Celsius. Means, this ice which is upside of 0 degree Celsius, it doesn't allow to lose the heat from this further water. Now, why is it important? Why nature might have given this anomalous behavior, this abnormal behavior to water? and just it is only for the aquatic plants and animals. Yesterday also I have told you, you just imagine the water doesn't have this abnormal behavior. Then what would have happened? Mainly in northern hemisphere of the earth, where the temperature falls below 0 degrees Celsius. Now there, this total water might have converted into ice, and all aquatic animals might have crushed into it. But it doesn't happen. As in water reservoir also, in the same way of Pope's apparatus. Naturally in water reservoirs also what happens? In the winter season, the temperature of water decreases up to 4 degrees Celsius. Now, when this temperature of water decreases below 4 degrees Celsius, it becomes lighter. And when it acquires 0 degrees Celsius, it converts into ice and it floats on the water. This ice completely floats on the water reservoir. Means upper surface of water reservoir is of ice, and below that water is present. Now this ice, we know ice is bad conductor of heat. It doesn't allow to pass the heat through it, and due to this the heat from lower water is not lost. Means that water doesn't acquire the temperature below 4 degrees Celsius, and therefore this water remains water constantly and aquatic animals can survive. So this is just revision of anomalous behavior of water. Now today we are going to start the next point, that is dew point and humidity. In that first we will see what is the humidity. This humidity we will see first. Now for that we have to divide just the component of air. What are the components of air? Air is composed of all gases. The mixture of air is a mixture of all gases, including dust particles and water vapors. This we have studied in earlier classes. Now means in air, water vapors are also present, and this humidity is decided according to or on the basis of this presence of water vapors. Now when water vapors are present in the air must be moist, but this humidity means the amount of water vapor present in the air are depending upon the temperature of air. Now as the temperature of air is greater, the water vapors, presence of water vapor or amount of water vapor in the air is less. And when the temperature of air is less, then the amount of water vapor present in the air is more. Means the temperature of air is inversely proportional to the amount of water vapor, or amount of water vapor is inversely proportional to the temperature of water. Now how is it seen? Just now we have seen what is the humidity, the amount of water vapors present in unit area of the air is called as humidity. It is also called as absolute humidity. Now absolute humidity means general humidity. What is the absolute humidity? It is the amount of water vapor contained by unit volume of the air. Now, this humidity of air, as we have seen, it depends upon the water vapors of the air, presence of water vapors in the air. Now, that also I have told you, it is inversely proportional of the temperature. Now, generally in summer season, the temperature of air is more, and therefore the water vapors are condensed in the air, and we say the air is dry. On the contrary, in winter season, what happens? The temperature of air is less, and therefore the amount of water vapors which are present in the unit volume of air is more, and therefore in summer the humidity of air is less, and in winter or rainy season the humidity of air is more. Now, means what? Suppose, what is the again we will see what is the absolute humidity or humidity of the air. The amount of water vapors contained by unit volume of the air. Now, at constant temperature, suppose T is the temperature of air and X is the amount of water vapor present in it. Now, before this, we have to also study the saturated air and unsaturated air. Now, what is this saturated air? There is a specific capacity of air at which temperature a amount of water vapor present in it is saturated, means is completely humid air. Means what? If we have to take example, it is observed that when the temperature of air is 0 degrees Celsius, you listen carefully, when temperature of air is 40 degrees Celsius, then the amount of water vapors present or absolute humidity of that air is 49 grams. Means what? If the temperature of air is 40 degrees Celsius, then it contains, its capacity is to contain the 49 grams of water vapors. Is it? Now this amount of water vapor is called as the capacity of the air, and this is per kilometer area of air. Now when the air with 40 degrees Celsius contains 49 grams of water vapors in per kilometer of air, then this air is called as saturated air. Is it? Now, if the temperature is same, but the amount of water vapor is suppose 28 grams per kilometer, then it is, this amount is less than that of its capacity. Therefore, when this amount is present in the 1 kilometer area of volume of air at the same temperature, at this condition air is saturated, at this condition air is unsaturated. Means what? When the air contains the amount of water vapor according to its capacity, then it is called as saturated air. When the amount of water vapor is less than its capacity at the specific temperature, then that air is called as unsaturated air. Now, related to this saturated and unsaturated air, we have to study the dew point. Now, to define the dew point, first I will tell you definition. It is the temperature at which the air is totally saturated at the specific temperature and more water vapors cannot be contained by that air. At that point, that temperature is called as dew point. Now, this to have dew point, it is the saturated air. When that temperature is there, then that air is saturated air. Again, we will take the another example to explain dew point. That is, suppose it has the temperature of 20 degrees Celsius. Or we will take the temperature of air, that is 37 degrees Celsius. And suppose this amount of water vapor present is 24.7 kilometers, 7 per kilometer. Now, this is not saturated air as specific temperature, means this type of air, in this condition we cannot say it is the saturated air, because the capacity at this temperature of air is to contain more amount of water vapors. Now, to make this air saturated, how much temperature must be there? According to this, at this amount of water vapor, the temperature of air must be 20 degrees Celsius. Then we can say this air is saturated. Means we have to decrease the temperature from 37 to 20. And this decrease in temperature or this 20 degrees Celsius for this amount of water vapor is called as a dew point. Now this again we can explain dew point with another example. That is, if we will take a bottle from freezer or the container containing ice, a bottle containing ice out of freezer, and if we will keep outside, then after few minutes we can observe the water droplets around that outside of that bottle. Now, why is it so? Does this water comes out of bottle? No. The ice into the bottle is melts. But what is outside? These droplets are from the water vapors from the surrounding air. Means due to the cold bottle, around the bottle what is there? Air is there. And we have studied air contains water vapors. Now these water vapors which are present surrounding air of that bottle, due to the cold bottle, they are condensed and they remain attached to the outside area or surface of the bottle. And this explains the dew point. Now, Again, we will just revise. We have revised the anomalous behavior of water. We have studied humidity, dew point of air, and saturated, unsaturated. Here we will stop.